All right, so let's go ahead and do some simulations. We'll do 3 examples using simulations to model chance behavior. So first example, in an attempt to increase sales, a breakfast cereal company decides to offer a NASCAR promotion. Each box of cereal will contain a collectible card featuring one of these NASCAR drivers. These 5 people, Jeff, Dale, Tony, Danica, and Jimmy. The company says that each of the 5 cards is equally likely to appear in any box of cereal. A NASCAR fan decides to keep buying boxes of cereal until she has all 5 drivers' cards. She's surprised when it takes her 23 boxes to get the full set of cards. She's super dedicated to getting all of these. Should she be surprised that it takes her 23 boxes to get the full set? So we're going to go ahead and use our 4-step process. State, plan, do, conclude that we talked about at the end of the last lesson. So the state step is just to restate the question that we're trying to answer. So we're trying to figure out what's the probability that it will take 23 or more boxes to get a full set of 5 NASCAR collectible cards. Because then we can figure out whether or not she should be surprised. Okay, plan step, we need to somehow state how are we going to use one of our options to simulate this process. So we need 5 numbers to represent our 5 cards. So 1's going to equal Jeff, 2's going to equal Dale, 3 Tony, 4 Danica, 5 Jimmy. And then we can use random integer 1, 5 on our calculator to simulate buying 1 box of cereal and looking at which card is inside. We want a full set of cards, so we have to keep pressing enter until we get all 5 of the labels from 1 to 5. And then we'll record the number of boxes that we had to open, and we'll repeat the simulation for, well, I don't have you guys in class right now since you're watching this video. So I'll do the simulation 10 times on my calculator by myself, and then we'll talk about the results. So I'll show you guys one simulation here. All right, with my calculator, we are going to go to math, probability, and then we're going to use random integer. So 1, 5. Okay, so first box I open, I get card number 3, Tony. Get card number 3 again. Card number 2, 2, 2, 5, 1, 3, 2, 4. Okay, I just got all 5 cards. So that took me 1 box, 2 boxes, 3 boxes, 5, 6, 7, 8, 9, 10. 10 boxes. All right, so first trial took 10 boxes. I'm going to go ahead and do 9 more trials, and I'll tell you the results in a moment. All right, so I went ahead and I did 10 trials. That first trial, I actually got 10, not 11. I counted wrong. Then I got 9 boxes. Then it took 20 boxes, 26 boxes, 7 boxes, 12 boxes, 15 boxes, 11 boxes, 6 boxes, 9 boxes. So I just did 10 trials myself on my calculator. Normally I have you guys each do 1 trial in class. From my 10 trials though, you guys can see only 1 time did I have to open 23 or more boxes. So that's 1 out of 10 times. So that gives me an estimation of 10%. So in conclusion, there's a 10% chance you will have to open 23 or more boxes to get all 5 cards. So should she be surprised? I mean, 10% chance, I wouldn't really be surprised. It's definitely possible to happen. And of course, the more trials we do, the more accurate results we will get. After 10 trials, we only saw it happen 1 time, so that is our estimation as of right now. Again, you could do 1,000,000 trials and you will have a much more accurate representation, but I am only one human, so we will stick with 10. All right, so for our second example, at a local high school, 95 students have permission to park on campus. Each month, the student council holds a golden ticket parking lottery at a school assembly. The 2 lucky winners are given reserved parking spots next to the school's main entrance. Last month, the winning tickets were drawn or the people who won were 2 students from AP Stats. When both golden tickets went to members of the same class, some people thought that the lottery had been rigged. There are 28 students in AP Stats, all of whom are eligible to park on campus. So let's design and carry out a simulation to see whether or not it's plausible that the lottery was carried out fairly. So in the state step, we restate the question, just restating what probability we're trying to find. So here we're trying to find what's the probability that both students selected to win the parking spots are from AP Stats. Okay. So in the plan step, we have to state what chance process we're using and how we're assigning numbers or whatever to outcomes. So let's use our calculators again. We have 28 students in AP Stats, and then we have 95 students total that can park on campus. So let's let numbers 1 through 28 represent students from AP Stats. And the rest, so 29 to 95, represent the other students. And then we will use random integer 1, 95 to select 2 students. And in this case, we don't want repeats because each number represents a specific student, so no repeats. And then we'll record if both students are from AP Stats. All right, so with my calculator, which we're gonna open right now. Okay, so go to math, probability, number 5, random integer, 1, 95. Okay, first student I get, not from AP Stats, 31 is another student. 63, okay, so for my first trial, 31 and 63, neither are from AP Stats, so let's do another trial. Okay, again, 85 and 63, not from AP Stats. Okay, third trial, 6 and 37, one from AP Stats, but both are not from AP Stats. So I'm gonna do this maybe 15 times, and then we'll see what happens. All right, so I did 15 trials. Here's what happened. I'm just gonna write my trials out. The first trial, you saw the first few, I got students 31 and 63. Then I got 85, 63, 6, 37. My fourth trial, I got students 21 and 4. So this trial, both students from AP Stats were collected. 54 and 1, 43, 25, 15, 85, 85, 57, 50, 71, 33, 62, 51, 9. So you can see kind of what's happening here. It's not happening a ton where I'm getting both students from AP Stats. Sometimes I'll get one student from AP Stats, but a lot of the time I'm just getting 2 students not in AP Stats. So it happened 1 out of 15 times. So the probability that both students selected to win are from AP Stats is 1 out of 15. So it's possible, it's just very unlikely. So is it rigged? Well, I guess it depends on who's running the show. Again, like it can happen, we saw it happen, but unlikely. 1 out of 15 chance. Okay, in the last example, we're going to use the random digit table. The random digit table can appear on the AP test, so it's nice to go over it. So just a couple of reminders when you use the random digit table. You have to make sure you're labeling your subjects with length. So if you have 150 students, you have to label them 0, 1 to 150 instead of 1 to 150. So you have to use 3 digits for every number. And then if you're not going to use all the digits, you have to say which digits you're going to reject. So if we have 150 students, we're using 0, 1 to 150. We will not use 0, 0, and then we would not use 151 to 999. So you have to say which 3-digit numbers you're going to ignore. All right, last example. Suppose I want to choose a simple random sample of size 6 from a group of 60 seniors, 30 juniors. To do this, I write each person's name on an equally sized piece of paper, mix them up in a large bag. Just as I'm about to select the first name, a thoughtful student suggests that I should stratify by class. So I agree. We decide it would be appropriate to select 4 seniors and 2 juniors. I already mixed the names up though, and I don't want to have to separate them all again. So I'm just going to select names one at a time until I have 4 seniors, 2 juniors. So this means I may have to select more than 6 names though, right? If I'm just pulling them out until I get 4 seniors, 2 juniors. So let's design and carry out a simulation of 10 trials using line 103 of the random digit table to estimate the probability that we have to draw 8 or more names to get 4 seniors and 2 juniors. All right, so here are our steps. State, we'll restate the problem. What's the probability? I have to select or draw 8 or more names to get 4 seniors and 2 juniors. Okay, plan step. We're going to use the random digit table. So I had, if we scroll back here, 60 seniors, 30 juniors, so I have 90 kids total. So let's let 0, 1 to 60 represent my seniors, and 61 to 90 represent the juniors. So that means we're going to ignore 0, 0 and 91 to 99. We're also going to have to ignore repeats because each of these numbers represents a specific student. So we will read table D, the random digit table, at line 103, 2 digits at a time. Nope, don't forget to say ignore repeats. Until I select 4 seniors and 2 juniors. All right, so here's line 103. First number is 45, so that is a senior. So first we get a senior. 46, that's another senior. 77, that's a junior. 17 is a senior. 9 is another senior. So we have our 4 seniors. Okay, 77, we already had that number, so we ignore that repeat. 55, that is a senior, and then we got 80, which is a junior. So that took 1, 2, 3, 4, 5, 6, 7 names to get 4 seniors and 2 juniors. So I'm going to go ahead and do this 5 more times actually. All right, so our trials were 7, then it took me 8 names, then it took me 6, and then it took me 9, and then it took me 7. So there were 2 times that it took 8 or more to get 4 seniors and 2 juniors. So that's the probability, 2 out of 5, 40% chance it's going to take me 8 or more names.